Good afternoon, everyone, and thank you for joining me today on my journey to story-based releases. This is an experience report on how this past 1.5, 2 years, I worked at a project within the public sector that was absolute chaos when I started. It was very frustrating, but it turned out to become the best project that I've ever worked on so far. Now, before we dive into this, allow me to introduce myself. My name is Mazin, and I was born and raised in the Maldives. For those of you who don't know where that is, you'll need to look it up on the map. You'll need to zoom in on the Indian Ocean, and you still won't find it, because it's so small. But it's there, believe me. So when I was 13, I moved to the Netherlands. And there, in high school, I discovered programming on the graphical calculator. And this is where my passion for automation actually began. But being a teenager, I didn't realize it. So I went and studied something entirely different. I studied aerospace engineering at the University of Delft. But luckily, I refound my passion for automation when I joined Capgemini as a test automation engineer. And since then, I have set up test automation for several projects, and I am a trainer at the Capgemini Academy and give courses on test automation. So, due to my test automation experience, I was asked to come in and set up test automation for this project. And today, I want to talk to you about my journey at this project from absolute chaos to the best project that I've worked on so far. I want to talk to you about how there was no testing done before merging a story. How I delved into the world of GitLab pipelines, Helm charts, and Kubernetes, so ops stuff. But always from a quality perspective, hence TestOps. But most of all, I want to talk to you about how the client wanted flexibility and the ability to release often, and how this led to a process enabling story-based releases. Now, I am a huge fan of fantasy books. Are there any other fantasy bookworms here? Nice. You're going to enjoy this. So the rest of this talk is structured as if we're navigating through a fantasy epic. And as the quest of any adventurer is setting out on an epic journey, it wasn't smooth sailing from beginning till end. We faced many challenges, and every challenge we faced and overcame, we got surprised with a new challenge, of course. So the first chapter is then also, because of this, we call it Out of the Frying Pan and Into the Fire. Now, this is a chapter from the book The Hobbit, and in this chapter, Bilbo and the dwarves narrowly escape the goblins from the Misty Mountains, only to find themselves being chased by wargs, evil wolves, and then they climb up into these trees, thinking to escape the wolves. But then the wargs, they go and get the goblins, and they set fire to the trees, so now they find themselves in even bigger problems than they had before. And this is how it felt for me as well at the beginning of this project. We had so many issues, and every time we solved an issue, we would face an even bigger issue. And yeah, so this chapter is going to focus on that. So it all started about 2 years ago when I was asked to set up test automation for this project. And let me give you a bit of context. So this project was for multiple websites that had a microservice architecture. So we had a front end that consisted of micro front ends, and we had a back end that was a lot of microservices working together. Now, each micro front end or microservice had its own Git repository. Let's call them components from now on. You needed all of these components working together to have a fully working application. And I soon realized that test automation wasn't the actual challenge here. We had other problems, namely the development process. What would happen? A developer would start writing code for a story. He or she would then push that change to the main branch of that component. This would then trigger that component being deployed to the test environment. Now, only then would testing come into play. And guess what? When they started testing, test environment was broken. Imagine a situation when you have more than 30 developers spread out over 4 teams working on these components for that same application. It would not be clear what broke it. Whose merge broke it? So an analysis had to begin to figure out, okay, what's broken, how did it break, and how can we fix this? But in the meantime, development work continued. Great. So remember that I said that the client wanted flexibility and the ability to release often? With this way of working, this was never going to be possible. So we needed to do something. Luckily, the dev teams were very open to experimenting. So that's what we started doing. We started experimenting. So we thought, okay, what if, when you've made those code changes for a component, what if we spin that component up locally and test that component in isolation? Awesome. We found bugs, we fixed them, great. But then we would integrate it into the system and it would break again, because integrated into the entire thing, there were other bugs. So we thought, okay, how about then we spin up the entire application locally on everyone's machines? But then we had the issue that everyone had a different machine and a different setup. So we literally had cases of people saying, it works on my machine. Great. So we needed to get out of this cycle of out of the frying pan and into the fire. We were falling from problem to problem. And that's why we find ourselves at the beginning of our journey to story-based releases, in need of a proper development process that would work for all 4 teams. Now, each chapter of this talk is a marker on this map, so you can all follow me as I go through this journey. And the first leg of our journey is the Council of Elrond. Now, the Council of Elrond fits my purposes here perfectly for multiple reasons. Not only does the Council mark the beginning of the Fellowship of the Ring, it's Lord of the Rings, actually. I don't know if the people that don't know it, but Lord of the Rings. So it marks the beginning of the Fellowship of the Ring. But if you focus on the Council itself, you'll notice that the Council is actually split up into 2 parts. First, there's a bit of storming. Everyone has ideas about what's important and what we should do with the ring. And then they actually come together in the second part of the Council, and they form their fellowship, aligning towards their common goal. And that's what we're going to do in this chapter as well. We're going to do a bit of storming, and then we're going to align towards our common goal, which is that the client wants flexibility and the ability to release often. So, the first part is test strategy storming. This is something that I picked up from a German colleague of mine, Catherine Potsdam. She works for Capgemini Germany. And she thought there would be an easy way, a fast way to set up a test strategy, and she based this on event storming. What it boils down to is to bring all of the right people together and to focus on creating a common understanding. Together, you would hash out the following information. First, you figure out which test stages do I need. So do I have unit testing, component testing, contract testing, integration testing, end-to-end testing? It doesn't really matter what you call these stages, as long as everyone involved understands what it stands for. Once you have the test stages down, you then look at the different test types. So we're talking about things like functional testing, performance or load testing, security testing, accessibility testing. So quality attributes. And we actually did a bit of risk storming to figure out which quality attributes were most important for us. So once you've created this matrix, you can now fill in the cells. And in each cell, you then write down, okay, which roles are going to be involved in this, which metrics are important, which tools are we going to use, and on which environment are we going to run this. And if there are any questions or anything that's unclear, you write that down as well. Now, once you do this for every single cell, you'll notice that not all cells are relevant, but you'll have an entire matrix with everything that's now important for testing. So you've created a common understanding of everything that you need for testing. Okay, great. Now what? Well, our dev process was broken because we didn't actually have a dev process. So let's see how we can implement this test strategy into our dev process. And that's what we're going to do in our second part, with value stream mapping. This is actually something that I picked up in a safe DevOps training. And value stream mapping itself focuses on calculating the efficiency of your process. But we didn't have a process. So I thought, guess what? I can use the theory of that training that I followed, safe DevOps training. I can use a theory of value stream mapping there to figure out what our process should be. So once again, we got everyone together and we started talking. What are the steps that we need to take to get a story from our product backlog all the way up to production? And here, once again, we focus on our objective, our common goal, that the client wants flexibility and the ability to release often. So for me, this meant that our main branch should always be deployable to production, should always be in a ready state. And that means you need to test as early in the process as possible. So I argued for using shift left here. And this is the point where I actually got into an argument with some of the architects at the client because they didn't agree with shift left. But that's a story that I can't fit into this time slot that we have. Maybe if we have time after questions, I can go into that. Anyhow, so using value stream mapping, we came up with our version of what our development process should be. And we decided that we needed development environments per team. We had a test environment, and we also said, oh, maybe we should have an ACC environment and a prod environment. You know, if you want to go live, that's nice to have. Once again, naming here doesn't really matter. This is what everyone was comfortable with. We were doing the brunt of our test work on the dev environments. And the test environment was where all of the stories were merged together and came together, and there was just a regression test that was running there. And the ACC environment was where we were doing our end-to-end tests, or chain tests they were talking about last night, end-to-end tests, and of course production. But this was the naming that they were all comfortable with. Sure, go ahead. So, at the end of our council, we now have a process that works for all 4 teams. We did this by using test strategy storming to figure out what was important for testing. And we used value stream mapping to define our dev process. And now with our fellowship formed, with our common goal in sight, we can continue our journey. But as soon as you start with a new process, you'll see that there are challenges to that process. And the chapter, The Gathering Storm, signifies the tipping point that these challenges led to that wiped away our entire code base. To be honest here, I haven't read the book, The Gathering Storm. It's a book in the Wheel of Time series from Robert Jordan. I haven't gotten around to it yet. It's on my list to read. But the title fit perfectly with what I wanted to explain here, so I just picked it. Anyway, this storm literally blew away our code base. So let me tell you how. Remember this microservice architecture that I told you about? And that each component had its own Git repository? So this meant that if you wanted to deploy to an environment, you would need to go into every single repository and run a pipeline to deploy that component to a specific environment. Not only that, if you were working on component A, you would not know whether component B had been updated in the meantime. So you wouldn't even know if you were working with an up-to-date environment. And to make matters worse, if you were working on a feature where you had to update multiple components, your changes would be splintered out over different repositories. So that meant that if you needed a review, a merge review, that the person reviewing would have to think, okay, so this change in Git in repository A corresponds to this change in repository B. They would have to keep track of that themselves, and you'd have to sync the approvals and merge them all at the same time, because if you only merge one thing or if you forget to merge something, guess what? Your application's broken. Now, if you only have a couple of microservices, this might not be that big of a challenge, but we had more than 50 microservices, and then you can literally see that storm cloud growing. So once again, we said, okay, let's start experimenting. So the first idea we had was, okay, how about we create a separate project that runs a pipeline, and that pipeline will then trigger all of the components to deploy to a specific environment using child pipelines. Okay, that helps with the deployments, but doesn't solve any of the other issues. Back to the drawing board. So then somebody came up with the idea of, hey, what if we use a monorepo? And a monorepo is basically putting all of your code, all of your microservices, into a single Git repository, but still deploying it as separate services. And, well, that was actually quite good, because this solved nearly all of our issues. So this would mean that if you were working on a feature that touched multiple components, you would now just have one single branch where you'd had all of those components and changes in there. And if you wanted to make sure that you were up to date with the latest version, you just needed to make sure that your branch was in sync with main. And you were up to date. Awesome. So we went from a storm cloud of microservices where our code was splintered out over multiple repositories to a single monorepo and improved our dev process. And improved the maintainability of our code as well. Now, this was a huge change, of course, because we needed to rewrite all of those components into a single repository, right? So it took a while to get there. I think one IP, so that's like 5 sprints that we did it in. But not all changes need to be this big to have an impact. Some changes can be small, like a spark. And the spark is a reference to book 2 of the Hunger Games. And the first part of this book is titled The Spark. And it refers to the fact that Katniss, at the end of the Hunger Games, she defied the rules of the Hunger Games, right? And then by that small act, she inspired a rebellion in Pan Am against the oppressive rule of the capital. And in this chapter, we are going to see how a small change can also spark our revolution and help us move forward towards story-based releases. So, with our move to the monorepo, with a single pipeline, we could now deploy the entire application to an environment. But this pipeline was very slow. Why? Well, all of our components still needed to be built every single time we ran that pipeline. Great. And we only had 1 or 2 dev environments per team. So teams were spending a lot of time saying, hey, are you using environment? Can I use the dev environment? Can I use the dev environment? So we were wasting time waiting for an environment to become available and wasting time on communication there. And we solved this when we started using Helm charts in combination with Kubernetes. For those of you who don't know Helm, Helm is a package manager. I'm not going to go into too much details. But basically, it allows you to keep track of the different versions of your built components. So this enabled us to say, okay, once you run a pipeline, we only need to build the changed components, the components that have changed on that branch. And for all the other components, we can use the version of the main branch. And once you then merge your branch in, the components the versions get updated, and if everyone syncs from the main branch, they get their updated versions of all the components again, which is awesome. And this was the spark for something that I had wanted for a long time, namely feature namespaces. Allow me to explain. In order to explain this, I need to first also explain our Git branching strategy. We were using GitHub Flow. For those of you who don't know, that basically means, I like explaining Git with a tree, that basically means that you have your main branch, which is the trunk of the tree, and every branch you create from main is a feature branch, and that's all you have. What I wanted to achieve was that every branch created from that main branch would have its own dev environment. But what's the difference then with the dev environments that we already had? Remember, we had these static dev environments, 3 of them, 1 per team, 4 of them actually, 1 per team. But what am I talking about with feature namespaces then? Well, using Helm charts, it was time for our own little revolution. Using Helm charts, we could now expand our pipelines to dynamically create up to 30 namespaces automatically. So whenever you create a branch, it automatically creates a namespace for you. A namespace is a fully working environment, a fully working dev environment, isolated from all the other feature branches. So this allowed the teams to test their entire story in a fully working environment in isolation from other stories, and they could clean them up automatically as well, because guess what? When you merge it, that namespace goes away. And so we had now given the teams the ability to not have to wait anymore. They can just test and get their work done and merge stuff because it's all been tested. So with the small change that we made to use Helm charts, we sparked our own revolution to get rid of the static dev environments and to create dynamic, short-lived feature namespaces which were fully working dev environments. And this revolution brings us to the last stage of our journey. Because we want to get to that castle. And in order to get to that castle, we have to fight the Battle of Hogwarts. Now, for those of you who haven't read or seen Harry Potter, maybe a few, I don't know. The Battle of Hogwarts is the last battle of the series. And this battle has been long coming. And it required actually a lot of preparation. Because in order to defeat Voldemort, Harry first had to destroy several Horcruxes, little pieces of Voldemort's soul. Without destroying these Horcruxes, it would have been impossible to defeat Voldemort. And this ties in perfectly with our journey as well. Because we needed to overcome the challenges that we'd faced up till now in order to reach story-based releases. We're not there yet, but if we had not overcome the challenges that we'd faced up till now, we would never have been able to reach story-based releases. Now, we need to fight our final battle, and for that, I need to go back to this overview that I've shown you. This image is incomplete. Why? Well, it is basically an abstraction of the components that our teams worked on, our teams build and maintain. But for the application to actually work, we needed to have connections to the outside world. We needed to connect to external parties as well. Now, I ignored this up till now in my story because, well, most of the time when you make a release, most of the projects that you make a release, they have maybe a release every month or every 2 weeks, maybe even. And in those cases, it's quite easy to say, okay, let's plan a release moment and then let's do a full end-to-end test with these external parties and make sure that the entire application is working properly so that we validate these connections and make sure that nothing's broken when we release this. But if you have to do an end-to-end test with external parties for every single story that you're picking up, that's way too much work, right? So maybe we shouldn't do story-based releasing? Have we done enough? Well, for some cases, the answer might be yes. But in this case, the client said, well, show me. I want to see that it's possible to do story-based releases. Okay, sure, let's try this. An extra challenge here was that our dev and test clusters could not even communicate to the outside world. Yay. So we were only using our ACC and prod clusters to connect to the outside world. So our ACC environment was the only environment that we could use to connect to these external parties. But that's way too late if you want to do story-based releasing, in my opinion. So I started asking questions. What's the goal of these end-to-end tests? What do we want to achieve with that? What are we trying to prevent? Which risk is there? And the answer is actually quite simple. We want to make sure that when we make a code change, that we do not break that connection to the external party, that we do not break the message that we're sending out to that external party. Okay, so how can I achieve that on our dev and test environments? So that's what I started focusing on. I thought, what if we, instead of sending out the messages to the outside, we catch those messages in a so-called test catcher. Now, this is something that I haven't seen anywhere else. And I see some people thinking, yeah, it's just a stub, right? Because you just send something to a stub. Well, it's different. Because the test catcher catches the message and stores it, allowing your automated tests to, at the end of the test, go out, fetch that message that was sent to the test catcher, and validate that message. What do you base these validations on? On the actual messages that we sent on ACC to the external parties. So we know that if we set up very strict validations, if a validation fails, then you've broken the message that you are sending out to your external party. So this gave us a way of having end-to-end confidence on our dev and test environments without actually connecting to the external parties. We got that feedback early on. And I see some of you thinking, okay, yeah, but what if you actually want to change something to that message? I still want to see that it works with the external party in some cases, on some stories that I work on, right? Not every story will touch the code that goes out to the external parties, but some stories might. So how do we do that then? Well, we made it possible to deploy that feature branch to an ACC namespace. Because you know when you pick up that story in Sprint that it's a story that's going to touch that connection. So we made it possible that in Sprint you can deploy it to an ACC namespace and do the full end-to-end test with the external parties. So what does this mean? Basically, we could now test everything that we wanted to test before merging a branch. So we reached story-based releases, meaning that when a team picks up a story in Sprint, they test it thoroughly. And when they merge it, it automatically goes through all the way to production. How do we get there? By using test strategy storming to figure out what was important for testing. By using value stream mapping to come up with our development process. By moving to a monorepo. By creating feature namespaces, dynamic, short-lived environments to test on. And by using test catchers to validate our end-to-end connections, our end-to-end messages. Now, this has been quite a journey. And I learned a lot on this journey. But I want to leave you guys with two of the most important lessons before I wrap this up. The first is the importance of the journey. I knew when I started the project that I wanted to do, that I wanted to have feature namespaces and that I wanted to have test catchers. But the dev teams were not ready for that. They needed to experience the journey themselves. They needed to go through this journey step by step and discover story-based releasing for themselves. Be careful not to jump to the end of your journey, to jump to your destination, because you might find yourself quite alone there if you have not taken everyone with you on that journey. The second lesson is the importance of experimenting. I was very lucky that I found a group of people that I could experiment with and that we could implement change with that. Because if you're afraid to experiment, nothing will change. But these teams weren't afraid to fail. They said, okay, if we break something, we'll fix it. So if you don't try anything, you won't learn anything, you won't fail, you won't learn anything. If you don't take the next step, you won't improve. So, as all of you leave today on your own journeys going out today to the rest of the conference, I wish you a lot of luck in the journey, a lot of fun in the journey, but most of all, have fun experimenting. Enjoy yourselves. Thank you very much.